3 hours after the maneuver, 3I Atlas emitted a burst of electromagnetic radiation. Not across the full spectrum, just a narrow band centered at 8.4 gigahertz. The signal lasted exactly 117 seconds. It repeated after a pause of 233 seconds. Then again. The intervals were not random. They formed a sequence. 2, 3, 5, 7. Prime numbers. At this point, the debate fractured. One group of scientists, led by Dr. Marcus Havel at Harvard, argued that the signal could be a natural resonance phenomenon, a rotating body interacting with the heliospheric magnetic field, producing periodic emissions. Nature can surprise us, he cautioned. We must not confuse unfamiliar physics with intent. Others were less convinced. At the Atacama Array, engineers noticed something else. The signal's polarization was rotating, slowly, deliberately, as if being modulated. This was no longer random, one analyst whispered during a live feed. It was responding. As the hours passed, a second wave of anomalies arrived. Portions of the object appeared to fade, not gradually, but abruptly, vanishing from radar and optical sensors alike. One fragment, tracked independently by ESA, simply disappeared. No explosion, no debris field. It was as if it had slipped sideways out of detectable space. Meanwhile, Earth felt subtle effects. Low-orbit satellites reported brief communication dropouts, not failures, pauses. GPS timing errors of up to 40 nanoseconds were logged across Europe. Magnetometers in northern Canada recorded a localized fluctuation of 12 nanotesla, unrelated to solar activity. Even migratory bird tracking networks noted unusual deviations in flight paths over the Mediterranean. Governments noticed. Encrypted channels lit up. Emergency meetings were called, then canceled, then rescheduled. Official statements were delayed. Carefully worded phrases replaced urgency. No immediate threat. Phenomenon under investigation. Silence where there should have been reassurance. Inside control rooms, the atmosphere was different. I remember one engineer staring at the wall of screens, arms folded, saying nothing for a full minute. Finally, he spoke. "If this is a machine," he said quietly, "it's not broken." And that possibility, still unproven, still controversial, changed the conversation entirely. Because machines imply design, and design implies origin. Where did 3I Atlas come from? Interstellar space, yes, but from where exactly? Its inbound vector does not align with any known stellar system. Its velocity suggests it has been traveling for millions of years. If it is artificial, it predates humanity by an incomprehensible margin. The mainstream explanation remains firmly grounded in caution. Extraordinary claims require extraordinary evidence. And yet, as one by one natural explanations fail to reproduce the observed behavior, the margin of doubt narrows. Maybe we are witnessing a new category of object, something between asteroid and artifact. Or maybe we are seeing the limits of our understanding. As the data continues to stream in, one fact remains undeniable. 3I Atlas is not behaving like anything we have ever seen before. It adjusted its path, it emitted structured signals, it interacted with its environment in a controlled way. And then, just before dawn UTC, it went quiet. No signals, no emissions, just motion, steady, deliberate, and unchanged. Maybe this is not an arrival. Maybe it's a test, or a survey, or a message we haven't learned how to read yet. In moments like this, it's tempting to ask whether we should be afraid, but fear assumes hostility. What if this is something else entirely? An ancient probe, a relic, or simply a traveler passing through, indifferent to our sudden attention. Maybe we're not witnessing the end, but an invitation to rethink our place in the universe, to accept that intelligence, like matter, may not be confined to planets and biology, that the cosmos may be older, quieter, and far more deliberate than we imagined. As of this moment, 3I Atlas continues on its altered trajectory, outbound once more, carrying its secrets with it. But the data it left behind is enough to occupy scientists for decades. And one question now hangs over every observatory, every agency, every quiet control room on Earth. If it could change course once, what happens when it does it again? Subscribe to follow the next update, because this story, whatever it truly is only just beginning.
Breaking news! At precisely 0241 UTC this morning, observatories on 3 continents detected a change that should not have been possible. An object already classified, already modeled, already explained, changed its behavior in real time. Instruments at the Atacama Large Millimeter Array in Chile registered an abrupt deviation in velocity. Within seconds, corroborating alerts arrived from ESA's tracking network in Spain and NASA's Deep Space Network antennas in California and Australia. Today, the impossible just happened. An interstellar object known as 3I Atlas did something astronomers did not expect, and it did it silently, cleanly, with no warning at all. This changes everything we thought we knew about how objects move through our solar system. Stay with us, because what you're about to hear is unfolding right now. And if you want more verified cosmic updates as they happen, hit like, subscribe, and stay connected, because this story is far from over. Within minutes of the initial alert, emergency data sharing protocols were activated between NASA, ESA, and several academic institutions. Harvard's Center for Astrophysics, Caltech's Jet Propulsion Laboratory, and researchers connected to the James Webb Space Telescope all received the same raw telemetry feed. I remember staring at the first data frame as it loaded, numbers scrolling, spectral lines resolving, and thinking that the system had glitched. But then the same anomaly appeared again and again. Hubble, still operating in low Earth orbit, confirmed it optically. JWST confirmed it in the infrared. The European Space Network confirmed it through Doppler tracking. This was no instrument error. This was real. To understand why this moment matters, we need to rewind. 48 hours before the event, 3I Atlas was behaving exactly as predicted. Its trajectory, inbound on a hyperbolic path from outside the solar system, showed a velocity of 58.3 kilometers per second relative to the Sun. Its distance was measured at 3.7 astronomical units, just beyond the orbit of Mars. Spectral analysis indicated a surface temperature of approximately 210 Kelvin, consistent with an inert, cold interstellar body. There were no outgassing signatures, no cometary tail, no visible activity. In every sense, it was quiet. Then, 11 hours before the event, subtle discrepancies began to appear. At first, they were small, almost dismissible. A fractional change in acceleration measured at 0.0008 meters per second squared beyond what solar radiation pressure could explain. A slight asymmetry in reflected light detected in the near-infrared band between 1.5 and 2 microns. The kind of things astronomers argue about in footnotes. But as more data came in, the pattern became harder to ignore. 7 hours before the event, 3I Atlas began to cool instead of warming as it approached the Sun. Its surface temperature dropped by nearly 14 Kelvin. No known passive object does that, not without expelling mass, and there was no mass loss detected, no debris, no gas, nothing. 4 hours later, the object's shape, previously modeled as elongated but irregular, appeared to change. High-resolution adaptive optics from the Very Large Telescope in Chile showed a tightening of its light curve. The variation smoothed out as if the object were becoming more symmetrical. No natural tumbling asteroid does this spontaneously. Shape change requires energy, controlled energy. Then came the moment. At 0241 UTC, the object altered its velocity vector by 3.2 degrees. Not a gradual curve, not a gravitational slingshot, a clean adjustment. Its speed increased by 1.9 kilometers per second in under 90 seconds. That corresponds to an energy change of roughly 4.6 times 10 to the 12th joules. There was no visible exhaust, no plume, no radiation spike consistent with chemical propulsion. No known law of physics could explain such a maneuver without some form of active force. This is where the room went quiet, one researcher later told me. Within minutes, simulation teams at Caltech began running gravitational models. Every known variable was tested: solar wind fluctuations, magnetic reconnection events, micrometeoroid impacts. None matched the data. Spectroscopy teams analyzed the object's reflected spectrum again and again, searching for transient gases or ionization signatures. Nothing. Dr. Elena Marsh, a computational astrophysicist affiliated with ESA, was among the first to voice what many were thinking, but few wanted to say out loud. If this were a natural object, she said during a closed briefing, we would expect chaos. Instead, we're seeing precision. NASA's internal assessment initially favored a conservative explanation, perhaps an unusual composition, an ultra-porous structure interacting with solar photons in an unexpected way, or a rare form of asymmetric thermal re-radiation, similar but far stronger than the Yarkovsky effect. These explanations were circulated quickly, almost urgently. No one wanted to jump ahead of the evidence, but then the evidence changed.